Welcome back. So far, we've explored your journey into cloud and edge systems engineering, uncovered what the industry is really like, and heard some incredible real world engineering stories. Now, I'd like to make this profession feel even more real. Instead of asking the usual question, what does your day look like? I'd like you to walk us through yesterday, hour by hour. What does a typical day in the life of a cloud and edge system startup founder actually look like?
I'd be happy to. One of the reasons I enjoy this field is that no 2 days are exactly the same. Yesterday started around 6:30 a.m. Before I even checked my email, I opened our cloud operations dashboard. Since our customers operate manufacturing plants, logistics centers, and industrial IoT platforms across different locations, the first thing I review every morning is the health of our distributed systems. I checked questions like, are all cloud services running normally? Did any Kubernetes clusters report failures overnight? Are all edge gateways connected? Did any industrial IoT devices stop sending data? Are our real-time data pipelines processing events without delays? Were there any cloud security alerts? Fortunately, everything looked healthy. One edge gateway showed higher CPU utilization than expected, so we flagged it for investigation. That doesn't necessarily mean something is wrong, but unusual behavior is always worth understanding before it becomes a problem.
That's interesting. So, your day begins by monitoring the entire system rather than focusing on a single application.
Exactly. Cloud and edge engineers think in terms of systems. One application might depend on dozens of cloud services, databases, APIs, message brokers, containers, and edge devices. A small issue in one component can affect the entire platform. Monitoring helps us identify problems before customers notice them.
What happened after you reached the office?
Around 9 a.m., we had our daily engineering stand up. Each team shared updates. Our cloud infrastructure engineers discussed improvements to our Kubernetes clusters. The DevOps team reviewed overnight CI/CD pipeline results. The Edge engineering team reported progress on deploying new software to industrial gateways. Our cloud security specialists reviewed authentication logs and zero trust policy updates. Meanwhile, the data engineering team discussed improvements to our real time streaming platform. One thing many people don't realize is how collaborative this field is. Cloud and edge systems engineering brings together experts in networking, software engineering, cybersecurity, infrastructure, industrial automation, and data engineering. No single person builds the entire platform alone.
That sounds like a perfect example of multidisciplinary engineering.
Exactly. A successful cloud and edge platform depends on many specialists working together. Everyone contributes different expertise, but all decisions ultimately support the same goal: building reliable distributed systems.
What happened next?
Around 10:30 a.m., we joined a customer architecture review. The customer wanted to expand their industrial IoT platform from one manufacturing facility to 10. Their biggest question wasn't about adding more servers, it was about maintaining reliability as the system grew. We discussed topics like which workloads should remain at the edge, which services should run in the cloud, how would data synchronize between locations, what happens if internet connectivity is interrupted, how should Kubernetes manage application deployments across multiple regions? Those conversations remind us that architecture decisions made today influence system performance for years.
So, architecture isn't just about technology, it's also about preparing for future growth.
Exactly. Good architecture solves today's problems while remaining flexible enough for tomorrow's requirements.
How much of your day involves writing code?
Quite a bit, although perhaps not as much as people expect. Yesterday, I reviewed infrastructure as code templates used to provision cloud environments. Later, I helped optimize a microservice responsible for processing industrial IoT messages. In the afternoon, I reviewed Kubernetes deployment configurations before a production release. Cloud and edge engineers often move between programming, automation, networking, infrastructure, and architecture discussions throughout the same day.
You mentioned infrastructure as code. Why has it become so important?
Imagine building a large apartment complex. Instead of constructing every building manually from memory, you use detailed architectural blueprints. Infrastructure as code works similarly. Cloud infrastructure is described using code rather than manual configuration. That makes deployments repeatable, version controlled, and much easier to maintain. Whether we're creating one environment or 100, the process remains consistent.
What happened after lunch?
Around 2 p.m., we tested a software update for our edge devices. These devices process sensor data inside manufacturing plants before transmitting selected information to the cloud. Testing involves much more than verifying that the software starts correctly. We measured CPU usage, memory consumption, network latency, local storage utilization, response times recovery after simulated network failures. Edge devices often operate in remote environments where uninterrupted connectivity can't be guaranteed. They must continue functioning even if communication with the cloud is temporarily unavailable.
That seems very different from developing ordinary web applications.
It is. Traditional web applications often assume continuous connectivity. Edge systems must assume exactly the opposite. They're designed to remain operational even under challenging conditions. That's one of the reasons edge computing has become so valuable in modern industries.
What came next?
Around 4 p.m., our DevOps team initiated a production deployment. Fortunately, the release pipeline was almost completely automated. Continuous integration verified the code. Automated tests checked application quality. Security scans looked for vulnerabilities. Kubernetes gradually rolled out the new version while monitoring system health. If any serious issue appeared, the deployment could automatically roll back. Automation dramatically reduces operational risk.
It sounds like DevOps is just as much about reliability as speed.
Exactly. People often think DevOps simply means deploying software faster. In reality, DevOps helps organizations deploy software safely, consistently, and repeatedly. Speed without reliability creates problems. Automation should improve both.
As the founder of a startup, I imagine your day isn't only about engineering.
That's true. Around 5:30 p.m., I met with a potential customer. Interestingly, they didn't ask, "Which cloud provider do you use?" Instead, they asked, "Can your platform reduce downtime? Can it improve operational visibility? Will it integrate with our existing industrial systems? How secure is it? Can it continue operating during network outages? How quickly can we deploy new facilities?" That conversation reminded me that customers don't buy cloud platforms, they buy business outcomes. Technology simply enables those outcomes.
That's an important perspective. Technology should solve business problems, not become the goal itself.
Exactly. Every cloud service, edge device, Kubernetes cluster, and data pipeline should exist because it solves a meaningful operational challenge.
Before we finish today's segment, what part of your work gives you the greatest satisfaction?
Seeing complex systems operate smoothly when thousands of connected devices communicate reliably, when a manufacturing plant continues operating despite temporary network interruptions, when engineers receive real time insights exactly when they need them, when cloud infrastructure automatically scales to support growing demand. Those moments remind us that behind every successful digital platform is a carefully designed cloud and edge architecture. Our work often remains invisible to users, but it enables countless applications they rely on every day.
That's a wonderful way to conclude today's discussion. We've learned that the life of a cloud and edge systems engineer extends far beyond writing code. It's about designing resilient architectures, monitoring distributed systems, collaborating across disciplines, automating deployments, protecting infrastructure, and ensuring that cloud and edge platforms work together seamlessly. In our next segment, we'll explore the future of cloud and edge systems. How will AI reshape distributed computing? What role will intelligent edge devices play? Which careers will emerge? And where are the biggest opportunities for startups and innovation? Stay with us for part 5.